All right, welcome. Today, we are tackling one of the most mind-bending, absolutely fascinating objects in the entire cosmos, the black hole. We're going to go on a journey from the explosive death of a massive star all the way to the ultimate point of no return, the singularity right at its heart.
But right away, that presents a huge challenge, right? I mean, think about it. How in the world do you find something that is by its very nature completely invisible? How do astronomers even begin to play this cosmic game of hide and seek?
Well, the very first clue actually came from right here, in our own backyard, cosmically speaking, the center of our Milky Way galaxy. Astronomers were looking out there, and they saw these massive, giant stars just whipping around at incredible speeds. And what were they orbiting? Nothing. Just empty space. It was this huge clue that something ridiculously powerful, something with immense gravity, had to be hiding there, completely unseen. So all these observations pointed to some kind of unseen giant lurking right at the heart of our galaxy. The big question then is, what exactly is it? Yep, it's a black hole. And the definition is actually beautifully simple, but totally profound. It's a place in space where gravity is so powerful that nothing, and I mean nothing, not even light itself, can escape. And here's a really key way to think about it, something astrophysicist Jana Lavin points out. It's better to think of it as a place rather than a thing. It's a region of space-time, the four-dimensional fabric of our universe, that's been warped to an almost unbelievable extreme. Okay, so how does one of these cosmic monsters even get created? Well, the story starts with the dramatic life and the even more dramatic death of a really, really big star. It really all boils down to one word: density. You see, black holes are hugely, hugely heavy, but they are physically tiny. So the key isn't just about how much they weigh. It's about the fact that an incredible amount of mass has been crushed into an impossibly small space. So, let's break down how this happens. First, you start with a truly massive star, way, way bigger than our own sun. For millions of years, it's in this perfect balance. You've got thermonuclear fusion, that's just atoms smashing together, creating a huge outward blast of energy, and that's pushing out. At the same time, you've got the star's immense gravity crushing inward. But eventually that fuel runs out, and with nothing left to push outwards, gravity wins. And it wins in a big way. The star's core just collapses in on itself, while all the outer layers get blasted away in this spectacular explosion we call a supernova. But that super dense core, it just keeps collapsing and collapsing, shrinking smaller and smaller until poof, it becomes a black hole. Okay, so we've made a black hole. Now what? What's it actually like? Let's take a look at the anatomy of this thing, including its most famous feature, the point of no return.
All right, this is the part everyone's heard of, the event horizon. Now, it's not a solid surface or anything you could touch. Think of it more like an invisible line in space. It's the boundary where the escape velocity, that's the speed you'd need to go to get away, becomes equal to the speed of light. And since nothing can go faster than light, anything that crosses that line, whether it's a spaceship or just a beam of light, can never, ever get out. It is the ultimate one-way ticket in the universe.
But wait, how does it actually pull things in? This is where we get into Einstein's genius. See, gravity isn't some invisible rope that's yanking on you. As Dr. Jana Lavin explains it, what a black hole is really doing is changing the shape of space around it. It's creating this incredibly deep curve, a well in the fabric of space-time. A black hole warps space so profoundly that literally all paths, even the path a beam of light is traveling on, are bent to lead right into the center.
So if you did cross the event horizon and kept going, you'd eventually reach the center, the singularity. And this is where things get, well, completely bonkers. This is a point that we think is infinitely small and infinitely dense. And right here, this is where our entire understanding of the universe just hits a brick wall. All the known laws of physics, they break down. They just stop working. It is genuinely one of the greatest unsolved mysteries in all of science.
So just to put it all together real quick, you've got the event horizon, which is the edge, that's the boundary of no return, and then deep down inside, you've got the singularity, the mind-bending, super dense core at the very center. Okay, this all sounds like some pretty wild mind-bending theory, right? But if these things are truly invisible, how are we so sure they actually exist? Well, that brings us to how we actually go about seeing the invisible. It's true, we can't see the black hole itself, but we can see the chaos it creates around it. For one, as matter gets pulled in, it doesn't just fall straight in. It spirals around, forming what's called an accretion disk. All that gas and dust gets so hot from friction that it glows incredibly brightly.
even shooting out X-rays. We can also go back to that first clue, just watching stars and tracking their orbits as they whip around an invisible point in space. And, maybe the coolest one, when two black holes actually collide, they send out gravitational waves, literal ripples in the fabric of space-time that we can now detect right here on Earth.
And by using all of these clever techniques, scientists did something in 2022 that most people thought was completely impossible. A huge team, the Event Horizon Telescope collaboration, unveiled the very first image of the supermassive black hole right at the center of our own galaxy. This black hole, its name is Sagittarius A star, is an absolute monster. Get this. It contains the mass of 4.3 million of our suns all crushed down into one spot. And just to give you an idea of how ridiculously hard this was, the team that did it said it was like trying to take a picture of a donut sitting on the surface of the moon. And that donut shape is actually the whole key. What you're seeing isn't the black hole itself, but that superheated gas swirling around it with its light being bent into a ring by the black hole's incredible gravity. To pull this off, they had to link up a whole network of telescopes all across the globe, basically creating a virtual telescope the size of planet Earth. Just a monumental achievement.
But even with this incredible image, we're left with the deepest questions. For everything we've figured out, we're still faced with a central mystery. So here's the most important point to take away from all this. A black hole isn't just a dead star, and it's not some cosmic vacuum cleaner. It's a place where our entire understanding of reality gets pushed to its absolute limit. It's a natural laboratory where our two greatest theories of the universe, Einstein's general relativity for the really big stuff and quantum mechanics for the really small stuff, come head-to-head and, well, they just don't agree.
And that conflict leaves us with one of the biggest puzzles in all of modern physics. Think about it. What happens to the information of something that falls into a black hole? See, one of the fundamental rules of quantum mechanics is that information can never be destroyed. But general relativity seems to suggest that, yeah, it's gone forever. So, which is it? Is it lost to the universe forever? That's a question scientists are still wrestling with today, and it proves that even after all this time, the incredible story of the black hole is far from over.